What if we told you that a process that is responsible for carbon dioxide emissions can be turned into a process that fixates carbon dioxide and helps us fight global warming? Approximately 40% of worldwide greenhouse gas emissions are attributed to the architecture, engineering, and construction industry. Concrete production that includes stone milling, grouting, and heat treatment at 1,700 Celsius is responsible for significant industrial carbon dioxide emissions. Our solution to such environmental challenges relies on a microbial living organism, Cyanobacteria. It holds the potential to revolutionize the construction industry and possibly solve our environmental challenges. Cyanobacteria photosynthesis is responsible for a major part of the global carbon dioxide fixation. It also enables a biocementation process, depositing calcium carbonate, which is basically production of sedimentary limestone.
This is a fantastic sustainable alternative for conventional solidification of building materials. The technology we offer uses state-of-the-art 3D printing to unlock the complete potential of cyanobacteria biomixtures within carbon-efficient building components.
Our team is a collaboration between the Technion Faculty of Architecture and Town Planning and Biotechnology and Food Engineering. Through our interdisciplinary research, we've forged a powerful alliance between biology and architecture, creating a seamless pathway from design to fabrication.
Biocementation is a phenomenon that occurs within soil as it results in binding of sand particles together. By harnessing light to perform photosynthesis, cyanobacteria cells grow, secrete extracellular polymeric substances, aggregate and form biofilms when in contact with solid surfaces.
The EPS includes precipitated calcium carbonate, a crucial component in conventional cement production. We harness these cyanobacteria biofilms to act as a natural adhesive, binding the biomixtures particles together.
Cyanobacteria biocementation presents a promising avenue for solidifying construction components, all while actively fixating carbon dioxide.
With light being the main factor that powers cyanobacterial photosynthesis, we utilize additive manufacturing, also referred to as 3D printing, a manufacturing process that fabricates three-dimensional objects by depositing materials layer by layer. This innovative manufacturing process allows for increased photosynthetic activity by maximizing the light flow through the geometrical articulation and structural porosity of the printed components. Additive manufacturing increases sustainability in life cycle assessments through minimizing the carbon footprint and reducing material waste. Therefore, the high cost of conventional building methods using scaffolding, concrete molds, and manual labor can be reduced significantly with the use of 3D printed construction.
We developed material protocols for cyanobacterial biomixtures that demonstrate carbon dioxide fixation and biocementation. We developed computational design tools linking biological and architectural performance to optimize cyanobacterial exposure to light.
We structured an automation workflow utilizing a customized robotic arm for the printing of cyanobacteria biomixtures at an architectural scale.
So what's next? Our results demonstrate the entire system's capability. In the next step, we aim to optimize the entire process of material protocols combined with 3D printing of cyanobacterial biomixtures.
We aim to employ our automation process to 3D print architectural scale modules. Full-scale prototypes will be carried out to demonstrate the feasibility of the production process. Finally, we aim to replace or augment existing concrete products with our bio-based carbon-efficient components.
In a world where climate change is no longer a distant threat, but an urgent reality, the detrimental impact of concrete and cement production cannot be ignored. We proudly introduce a game-changing bio-based building material, one with the potential to reverse the negative impact of the construction industry on Earth. Together, let's imagine a world where our homes are built not at the expense of our planet, but in harmony with it.